Today, almost everyone interacts with agents using either a chatbot like ChatGPT or development tools like Cursor. The common thing about all these things are these agents are tightly bound to a user interface, but not all agent conversations are interactive. In fact, we see a future where the majority of agent conversations will be agent to agent, not necessarily just human to agent. So, what are the implications of this on the agent architecture and the agent ecosystem? Well, welcome to the Agentic Mesh podcast. My name is Eric Broda, coming from Toronto, Canada, and
Co-host John Miller from San Francisco.
our topic today is ambient agents and the emergence of agents that run in the background, always on, always listening, and always working. Let me tell you a little bit what we're going to talk about in detail here. We're going to talk about how how agents are used today. Again, mostly tied to a user interface. And while we think this is incredibly powerful, it does lead the market to believe that this is the preferred or perhaps even only way that agents work. But is this really the case? More importantly, are there other agent collaboration approaches? And obviously, spoiler alert, we think there are. We're going to introduce this thing called ambient agents and explain why we expect them to actually proliferate. We're going to explain what they are and how they work. And of course, there's going to be some significant architecture implications. We're going to talk through them, point out what you need to consider as you build out your firm's agent ecosystem.
When you proposed this topic, I was thinking, why do you think this is so important to say right now? And I think it would be good for you to frame, why are we getting into this right now? Why do you see such a disconnect between what we're calling ambient agents and the chat interface that most consumers that are using AI are very familiar with?
So, John, you're actually quite correct. If you think about how agents are used today, it's almost all through things like ChatGPT. It has 800 million weekly users. It's a huge portion of the global population, if you think about it. Then you probably see this as much, oh, probably a lot more than I do even. Things like Cursor and Replit and similar products, they're literally changing the way we develop software. So is there really anything wrong with this? Well, I think for certain particular use cases, like the ones that folks are using ChatGPT for and Cursor, they're optimal. But not every experience is interactive. Not every interaction with an agent needs to be tied to a user interface. So that fundamentally is what we think is the difference, and why that other set of use cases that we'll talk about today are actually going to outweigh, I think, and we think, outweigh the use cases that are there today. So, long story short, we think it's a great thing that's happening, but we think there's other opportunities out there, and that's where ambient agents come into play.
So we often talk about distributed computing because it's been around for a long time since the network became important. And so I feel when you brought up this topic that distributed computing is a well understood area of practice. And so why wouldn't anybody automatically assume that agents needed to be able to work in a distributed, what we used to call, there used to be a product or a point of view called the distributed computing environment, or DCE, if you remember that hundreds of years ago, I think about 30.
Yeah.
And so why do you think that it's important to talk about distributed computing as it relates to agents now? Because I think that's where you're going to make the case that we need to be thinking more broadly.
Yeah, absolutely. I think there's probably two analogies that I'd like to kind of introduce. One we've talked about before, but I'm going to bring it up again. The first analogy is agents are kind of like people. And in the sense that they collaborate extensively, they work in teams, they organize themselves into large groups, even firms and companies. But the common thing about these collaborations is they're long running. Yeah, some of them are short and immediate, but most business conversations are related to completing tasks, some of which may take a minute, some of which may take an hour, a day, a week, or even longer. So the bottom line is when we think of agents as people having long conversations to get work done, collaborating extensively, we actually see agents doing the same thing. Now, the second analogy I think is as appropriate and as important. Is agents are, when you boil it all down, they're applications. They run behind the scenes like applications. They're going to collaborate behind the scenes like applications. And unless something breaks, they're going to run forever. And obviously, when something breaks, a person gets involved. What that really means is we're going to have an ecosystem of agents. Not every single agent is going to be tied to a person through a user interface. It's not practical, it's not effective, and it's definitely not efficient. So if you need them to run in the background, and if you can run them in the background, why not? And I think that's where the question around distributed computing actually comes into play. First off, distributed computing at a macro level, it's a known problem. We have been doing this. Computing has whether one could argue they've perfected or perhaps not, depending on your perspective. But it's a known problem, but it's not a simple problem to solve. Things like security concerns, which you don't have to deal with ChatGPT or Cursor, at least not a lot. The
Right.
blast radius of when stuff breaks is relatively small with ChatGPT and Cursor, and it makes for a great demo. But distributed computing is a different animal.
Okay, so let's make this practical because I was playing with one of the agentic platforms the other day, and this example I think will resonate with people is if you want to run a simple experiment quickly with AI agents, you have to kind of think about so many things to get it to work. The first time I tried to do a document processing solution on a studio of an agentic AI platform, I realized that I could figure out all of the integration issues around security to all my Google Docs, or I could just upload it directly. And so I think what you're saying is that we've become accustomed as consumers to mitigate the security risks and all of that by just letting us upload any document we want. That also presents privacy concern. But what you're saying is that if you take the human out of the loop, where the human gets to make judgment calls about what documents they upload, then you have to give it to somebody as a responsibility to be thinking about the security of the
Sure.
documents that you're loading and whether that agent is even allowed to read it. And so I think this analogy you're using about agents as people, agents as applications, and talk about security, that makes sense to me. And I really think that that's important example of one of the hard problems that's easy to solve in a UI based system, but harder to do when you've got asynchronous distributed agents communicating over time. And so I was thinking about that as you were talking.
Yeah, well, I think that the interesting thing about it is sometimes we're lulled into a sense of complacency, perhaps. When you're using ChatGPT or Cursor, there's that sense of immediacy and interact. There's a responsiveness that is actually very exciting and very powerful. There's also a very limited boundary. It's on your laptop or your server, and yeah, maybe you're accessing some cloud services, but for the most part, it's a relatively localized or well known environment. And as I mentioned earlier, when things go wrong, the blast radius is relatively small. But to your point, when these agents are decoupled from a user interface, they have that obviously the sense of immediacy is gone. So we need to figure out a way to have them actually talk to each other. The boundary has expanded dramatically. They're running in the background. Like any application, without security, without careful security, things can actually go wrong quite quickly. And they're no longer in your own environment. They're running in a contained environment, whether it's on the cloud, on-prem, or elsewhere. And what this really means is the architecture concerns are very, very different. Where when you're using Cursor or ChatGPT, a lot of the stuff is taken care of for you. Security, just as a simple example. When you're running agents and they're disconnected from the immediacy of an individual user and the security context of that user, you actually have to think about things very, very differently. This is, again, a known problem in distributed computing. Doesn't make it easy to solve, but it's a known problem. There's known patterns and known solutions for addressing that.
Well, the other thing you said, and so I agree, and I think it'll be good once we get into some of the known failure modes as you talk about and some of the architecture patterns that could work. One of the things I wanted to talk to you about though is when you think about and I want to use the human analogy. Like when you think about a large team of people working on a project, say an IT project that spends a year, right? I've been a consultant before where you start the project and after 3 months, everybody says, actually, take your pencils and put them down. We want to pause the project. We might restart, but we're not sure. And so restarting a large project with 100 people, it's a hard problem. And it's also going to be a hard problem if we had 100 agents running it. And that example of how hard it is for human beings to maintain a constant communication and a stateful conversation requires that we either keep notes on our notepad, or we have to keep a track of it in our memory, or we have a common document that we say, well, this is what we've talked about so far. These are the notes from the meeting, and this is as far as we got. So I just want to continue to find ways to take these agentic problems and make them and draw that analogy, like you said, back to how would human knowledge workers solve that problem?
Absolutely. So why don't we probably let's take a quick step back here. We'll continue the analogy as you highlighted, but we've talked about ambient agents. We should probably, and we've kind of hinted at what they actually
Yeah.
are, but I think it's worthwhile having some level of formality, I suppose, around the definition. So there's kind of three things that we see, and there's architecture implications under each of these. But if I were to characterize it in a pithy phrase, they're always on, always listening, and always working. What that really means is they're running in the background. They wait for work. When work arrives, they create task plans, execute the work. They're always observing and acting on what they see. So in their environment, whether they're listening for market events and then doing something with those, or listening for requests from people or other agents, they're listening and then acting based on that information. They're doing that continuously. They're long running. Like business processes, like when I try and open up a banking app, when I do a simple one, it can happen near immediately, checking countless and a few quick dialogues with a teller, if you will. But if I'm trying to open a complex account, maybe foreign currencies or investment accounts, all of a sudden these things take long periods of time. So like business processes, and agents that participate in those business processes, yes, they can handle complex and even ambiguous workload, and they can seek help when they need it. But these agent conversations are very, very long running. So when we think of ambient agents, always on, always listening, always working, they run the background, they're continuously operating, and they have long running conversations. Now, these have some pretty darn significant architecture implications. A lot of them are related to this notion of distributed computing. Does that definition, John, resonate with you?
Yeah. So I want to keep it really simple. When I think of analogies to that, what do we have that is long running, always working, operating in the background? I think of like the utility system where we provide electricity for homes. Nobody's consciously, well, actually, I'm sure there are operators in the power generation side and the transmission and distribution side that are constantly monitoring, but the system itself has to monitor itself. It needs to be able to produce or provide electricity when required. I don't think electricity has a lot of state, but maybe it's not a great example. But I also think about systems in an embedded system. So, like in a car, a car has systems that need to turn on and be reliable and operate until you turn off that system. So I don't know if those were helpful analogies, but I'd love to
Well, I
put
think
this in the context of some other industry or problem as well, if we think of
yeah.
one.
So let me just give you let's go on the bank account open thing. I did have the privilege of opening up an investment account a little while ago, and it took about 40 days, give or take. And I love this bank, fantastic people. But here's what ended up happening over those 40 days. I had probably 10 to 20 emails, probably the same number of text messages, phone calls, talking to people, explaining things, at least five or six. So if you think about, the long running nature of that, the conversations that need to take place. That's one thing. The interesting thing about it is I typically dealt with one or two, maybe three people max. But I know, having come from the banking industry, there's a lot of stuff happening in the background. There's a lot of
Yeah.
people that are doing all the work that you don't see. These are people, like agents, if you will, that run in the background doing the work that you don't see, but nevertheless that work is necessary and it is required to get done. And when it gets done, you see the end result, but you don't see the work that actually goes into making it happen. So that's an example, a banking example, but I think is just appropriate, as appropriate using your example around utilities and other areas where there's a lot of stuff happening in the background that you just may not see. That's what ambient agents are. They're the that are running in the background, always on, always listening, always working, that you don't see that are actually doing the work.
So if we talk about this future state where we have ambient agents that can do all of these things that you're talking about, it feels like we're quite a far way away from there. It doesn't feel like that's what anybody's talking about as these long running agents and how they're supposed to work autonomously. Is that your experience?
Well, I think we're today, I would argue that we are, I wouldn't say very far away, but there's still some work that needs to be done. I think there's a little bit of a trap that we get into, the chatbot trap, if you will, but it is very easy to remain in that, that chatbot environment or the IDE environment for Cursor, for example. And until you actually see practical needs on how you may actually do things a little bit differently and come up with a slightly different architecture, until you actually see that, doing what you're doing is pretty satisfying. I think also there's a tendency, if all you have is a hammer nail problem, if all you have is a hammer, everything looks like a nail. If all you're used to is a chatbot type interface or an IDE, then that's the tool of choice, and you're going to use that for all of your solutions, even if they're not necessarily optimal. So I think that's a common trap that folks fall into. I think though what we're seeing in the industry is a turnaround. So I'll give you a few examples that I've seen, and then we can talk about how to actually go about doing this. But if you look at some of the standards that are emerging, A to A, Google's agent to agent protocol, starting to pick up some steam. There's some complexity with it. Agreed on that. But here's the thing is it is gaining some traction, and it is explicitly, as you can tell from the name, agent to agent, it's about agents collaborating at scale. So industry leaders like Google, who offered this spec, and other companies are actually implementing this capability. So they're preparing for this. We see MCP, Model Context Protocol from Anthropic, and it's a standard that allows agents and LLMs to actually talk to tools in a rather seamless way. These tools are implemented as microservices, in other words, distributed computing entities. So we're starting to see this whole notion around agents and their tools becoming distributed. They are distributed entities, just like applications, distributed entities running in an agent ecosystem. So it's a bridge that still needs to be crossed, but it's not a bridge too far. It is something that we're starting to see some serious thinking going on. And we're starting to be able to apply patterns that we've known and loved, if you will, if you're a distributed computing nerd like me. These are patterns that you've used for a long, long time. You're starting to see the stuff that we learned and practiced 10 years ago around distributed computing started to be implemented in the agent ecosystem. So yeah, there's still work to be done, but I think this is something, it's a trend that's not just emerging, but I think it's starting to really take hold.
Yeah. Well, I'm glad you mentioned A2A, Google's protocol. I did go to a Google meetup a few months ago and just recently, and I would love to share some of that in a field report in a subsequent podcast. But I think you're right. I think companies like Google are leading this conversation around distributed computing and agents, even having what I was told was their business card, right? So an agent's description is its business card. And I thought, well, that's one way to take the analogy of a human and apply it to an agent. Maybe not the most effective way because business cards are notoriously useless for explaining what that person does. But, you know, and this isn't to take swipes at Google, but we're at the very beginning of this discussion of how to think about if you had millions of agents, how would you know? Like, what would you call them? How would you address them? I think that interesting problem is part of what has to be solved.
Yeah, absolutely. Now we're starting to get into what I think are some of the architecture implications. And the very first one that you mentioned is I would categorize that as under the banner of identity. So A to A, for example, has this notion of agent cards. And it says, among other things, this is kind of the name or identity of the particular agent. It also says, for lack of a better analogy, the language that it can talk to and the dialects that it can talk to. It says what protocols it can use, HTTP or JSON RPC or gRPC or others. So there's a bunch of things that are actually very important and useful in the agent cards. Again, the analogy to a business card starts to break down, but identity is a formal architecture concern within ambient agents, and in particular demonstrated through A to A. A to A also has a few other things. So I'll just use A to A because I think it's the leading case for specification around ambient agents. It fully recognizes that agents are headless. Yes, people can interact with these ambient agents or headless agents. And headless, by the way, I should define it. Headless is a euphemism for saying that something without a user interface is termed headless. But the whole idea around A to A and MCP is that there's no user interface that's tied to the actual agent or the tool. Yes, a human can actually interact with it, but they go into a user interface. Yes, absolutely. But they send messages. The agent is not cognizant of the user interface. So they're headless.
Now,
John, looks like you have a question, so I'll turn it
well,
over to you, my friend.
I just think we need to talk about whether we call it a headless agent or not. I know this isn't meant to be a debate, but when you talk about an agent, we often say it's got a brain or it's got some way to think. And to say you've got a headless agent, does that mean a dumb agent? Like an agent that's not very intelligent? So I personally feel like I don't know who in tech who's started coining these term headless. You know, I remember seeing it in Beehive, but I think headless is a silly way to describe an agent. I much prefer your term ambient agent or something else, something that is without a UI.
Yeah, fair enough. So point taken. So let me look. That being said, let me touch on a
Yeah, yeah.
few other pieces of the puzzle. So we've talked about long running conversations. What that really means is over the course of a long period of time, the conversation may pause, it may stop, it may break. And what you need to do is be able to restart those conversations. But in order to restart, you actually have to understand where that conversation is and where it needs to go. That's the stateful nature of these conversations. So in the old days, I remember designing microservices. It was a faux pas, an anti-pattern, if you will, where you had microservices that were stateful. You tried to make them as stateless as possible. Now, sometimes there's a ambiguity in that definition, but make no mistake about it, agents do maintain state. They maintain state about their conversations and where they are, so they can, if necessary, pause and get human feedback. Or if they break, they can restart seamlessly without any errors and such. So the whole notion around statefulness is core. John, obviously you tweaked some questions here.
No, well, so when I bring it back to human examples, okay, and I'm not trying to anthropomorphize the agents more than we already have, but when Zoom fails and our conversation gets interrupted, somebody has to rejoin the call, there's a feature in Zoom now, which with the AI companion, which says, catch me up. And so it'll summarize everything that people have been talking about in that one meeting so that you can catch up. But it's notoriously hard for humans to keep track of their state of multiple conversations over multiple meetings over multiple times. It feels like a very difficult problem that we tried to build systems to solve, like customer support, customer relationship management systems. Were theoretically going to be the place, we keep track of all of your communication with the customers and we theoretically can know what we last said to you. But if CRM systems have proven anything, it's that customer support has not gotten better because we're using CRM. Maybe marginally, but I think human frustration with the inability of current companies to maintain state is an ongoing problem now. Why do you believe agents will somehow make this better or easier? Or tell me how you're thinking about that. Because I think when I question where agents are going, I realize that the humans that are doing this with the current systems, it isn't working very well.
Sure. So I think there's a bunch of different reasons. First off, distributed computing is a hard problem to solve, but largely the industry best practices patterns have solved that problem. Here's the problem. Here's the issue is there's only a few folks, Google, Microsoft, and the like, that actually have to deal with things at the scale of thousands or millions or what have you. So the skill and the capability is largely localized with the large players. So when I think about even the biggest banks, and I've worked with some of them, or the biggest insurance companies, I am a financial services person for the most part. Even with them, there's very few things where there's thousands, let alone millions or tens of thousands or hundreds of thousands of anything other than customers that they actually deal with. And as you know, when you're dealing with customers in a large institution, bank, financial services, or elsewhere, there's entire organizations, hundreds, if not thousands of people that manage those customers. You can't do that at scale easily unless you actually can automate a lot of that. And the only folks that have figured out how to do that are the hyperscalers, if you will, because they've had to. So why haven't we seen it? It's because it's a hard problem to solve, and the average company, even the largest one, don't have experience with it. But the knowledge that Google had and some of the other hyperscalers is now public knowledge through things like A to A and MCP. So we're starting to see specification standards, patterns even evolving rather rapidly, I would say, that actually show us how to actually deal with how the average mortal in a financial services company can actually acquire superhuman skills and do something that only the big players have been able to do before. So we're starting to see that common practice and patterns coming into in broadly, making it broadly available, and that's why we're starting to see some adoption there.
So you were telling us about the architecture patterns required to build this foundation. So you talked about identity being one of them. What are some of the others? And fill in the rest of the picture for us.
Yeah, I think in a roundabout way, we actually talked about each of them, but I'll summarize them very quickly. I promise not to use the word anymore after this, but headless, or they operate without a user interface. They are ambient, John. They're ambient, always on, always listening, and always acting. So that's the primary architecture implication. You have to design for that. They're distributed. We've talked about that just a moment ago. They have identity and they're stateful. So these are the architecture implications that we now need to think about designing for, so that we can actually get some traction around the agent ecosystem. Now, the obvious question, I think, is what makes distributed computing so hard? And I think it's actually like, I'm going to boil it down to something really, really simple. First off, distributed computing is hard, but the vast majority of distributed computing is stateless in nature. APIs, microservices. The new wrinkle that agents bring in is this notion around statefulness and long-running conversations, as opposed to the 100 millisecond time frame that you had to live with APIs and microservices. So going from 100 milliseconds to potentially 100 hours is a very, very different problem to solve. And being able to introduce state and restart recovery, these are all wrinkles that make distributed computing a much harder problem to solve than what we've run into before. And as I said earlier, the practices around doing that are starting to come out. So it's a problem that we're going to solve, but it's nonetheless a hard problem, and it does require a level of consideration that is probably not necessarily commonplace yet within a lot of large companies.
So I like where you're going with this. You got me thinking, what are some examples of how humans, groups of humans, solve problems at scale? And we talked about a project. A project is a way, or a program. These are two terms that are often overlapping and used in the same way sometimes, but usually a program is a bigger activity or set of activities than a project. A program usually has multiple projects, whatever. The point is, in order to organize a project team, we have project plans and we have project software and we have messaging boards and all of these things that humans use to communicate sound like they're the kind of tooling that agents, well, I mean, we're in the abstract projecting the future, but what do you think when you think of how do you coordinate And I think coordination is the key word. How do you coordinate, 100 agents? And I think there's a big gap for me personally in seeing what that's going to look like in the future when we have thousands of them. Are they going to be 100-person projects, 5-person project teams? And so I just wonder, as we think about this today, what do you see or what do you envision?
Yeah. Well, I think you're spot on in the sense that there's analogies out there, especially around how people do these long running conversations, et cetera, and how they organize. So I'll just use some common things that we see, not just necessarily just a project or a program, but you go from single person to teams. Then you see teams of teams working on, but you also see other organizational constructs. You may have groups, you may have a geographic organization, part of a bigger company, maybe a UK business unit, or a Canadian one, or a US one. So people have found ways to manage scale, and that's effectively by organizing themselves in a way to achieve objectives more efficiently and effectively. Same thing for agents. We have teams of agents. We call them fleets. We have fleets of fleets. We call them ecosystems. And just like organizations with people, we have ecosystems for agents. So yeah, we use slightly different terminology, but the concept is the same. So those organizational mechanisms to actually allow that. But the other thing that people have figured out is, independent of how I organize, there's ways that I can actually share information. So obviously we can talk, but we also have tools like email. We have Slack where we can have shared conversations. Same thing for agents. So we see actually three different types of agents that interact in an ecosystem. There's observer agents that listen for things, a market event, a document's come in that's important, and I need to go and process it. So these are observer agents that recognize some stuff has happened. They do some thinking about it with their LLM, their brain, if you will. And then they add some additional insight and potentially forward it to someone else. That someone else or another agent may be a task-oriented agent. So that task-oriented agent says, I have a bank account to open, and here are the 5 steps I need to go through. And I'm going to delegate that to other agents or tools. So there's ways of actually having collaboration between agents. The equivalent for people is something like email, for example. But we also have this notion of shared workspaces that agents can actually collaborate with at scale. The best analogy that we have is Slack. So Slack for agents allows agents to collaborate at scale, allows them to share information in real time, in detail, and be able to look at historical information, what other agents have said, for context about how they would actually go about addressing or adding to a part of a solution to a broader problem. So, you know, the analogy with people is actually quite appropriate, in how they organize, but also how they share information. And we think strongly that that is probably the first step. That analogy in being able to draw the likeness to how people do these things today is probably the most appropriate way to start looking at this problem.
Great conversation again this week, Eric. I love it. I don't know if there were other points that you wanted to make.
Yeah, I think there's probably one or two things that I'll mention. So now I'm gonna first ask you. I don't know if I was very convincing or not, but ambient agents, flash in the pan, or are they the future, John? What do you think? What do you hear in the valley?
Yes, I am closer to the action, but what action am I close to? So let me answer the question in two different ways. So, one of the things that I find fascinating is this concept that Anthropic just put out a paper on November 26th called Long Running Agents. And I was looking at that before our call. I think everybody is starting to get that you need a UI to talk to the human. Then the agents have to go do something and come back. And I think we all get that. We're actually doing what's called knowledge work. It's very different than everything we've seen before. So when I think about what's happening here in the Valley, I think there's a whole school of thought of people that are working at the command line. Their customer is a developer, right? And so developers work on the command line. So Claude code, you fire it off, it generates a script, runs a bunch of stuff, comes back. I think that's one user experience that's not going away, but I think it is so imperfect. It's so obviously wrong that I don't know what to say about it other than we have not brought the designers in to think about what the experience should be for the human that's commanding the agents to go do something. So I see us spending a lot of time talking with the command line interface in the Valley, and that's one point of view. The other thing I see is that, of course, we need agents running in the background. And so if you call these background agents, I love it, right? Because that just is a simple way to think of foreground or background, or they're backstage, they're operating, they're ready when you are ready to ask them to do something. It's almost obvious that we're going to need to be able to background agents and have them, and how we make that code and those system infrastructure layer. I think that's providing a point of view on what we see from two different lenses, my lens and your lens, on how we see this agentic mesh, this foundation evolving.
Although the podcast is called the Agentic Mesh podcast, the phrase agentic mesh, I think, is actually so appropriate and so necessary at this point in time. So we've talked a lot about, what ambient agents are, the architecture considerations, but fundamentally, if you actually read between the lines, these are all ecosystem services. So here's what my belief. First off, I agree with you 100%. Almost intuitive that they're going to be background agents. This is definitely not a flash in the pan or the future, but the question in my mind is, how do you accelerate that transition? And I think there's a few things. First off, it goes without saying that agents that run in the background, ambient, need to have enterprise grade capability. So security, we talked about that, really the whole notion around distributed computing, but that's not enough. Enterprise grade agents are one piece of the broader agentic puzzle. We need a commensurate investment in standards, capabilities, patterns around ecosystem services. Now, we have a good start on some of them. So A2A, for example, has discovery, and it allows agents to collaborate. And it allows some level of observability, but it's agnostic to state management, for example. And it does have a point of view on long-running conversations, but the implementation is really left to the implementer. And the spec is somewhat agnostic to it. What we need is patterns, reference sources that show how this agentic mesh actually can be put together. So the question is no longer, how do I build great agents, but how do I build great agent ecosystems? And that's kind of why we call this the Agentic Mesh podcast, because we think that is the next frontier. It's about the agents, the agent ecosystem, the agentic mesh.
Yeah. And I think we're going to have to come up with a whole new set of patterns to deal with some of the challenges of knowledge work being deployed to a group of agents. People might have heard, but Anthropic has gifted MCP to the Linux Foundation. So it is now an open source standard. And I think when you talk about standards, I think that is the one way that we as a community can protect everybody's access to new technology. And so I think you're absolutely talking about open standards that aren't controlled by a single ecosystem player that creates a walled garden that only a few can play in.
Yeah, so just a quick comment. I did see the announcement. The Linux Foundation is the standard bearer for open source, at least is one of them. So when I hear news like this, it just gives me a wonderful feeling that we are moving in the right direction. Standards are the first step in this long journey. We need reference implementations, for example. Some people are building those. We need the whole notion around how the ecosystem services are going to be held together. But these things are starting. So this is a case where the rising tide is lifting all boats, and this is such welcome news. It's fantastic. Now, that probably begs a longer discussion in a future podcast.